We're going to start this afternoon session with John Lee. John's with Agvice. We're going to talk on, I think he's going to give us an update on the soil samples that have been tested this fall and a little bit on plant tissue analysis. John grew up livestock and grain farm in southwest Minnesota and has been in the soil testing industry for about the past 28 years. The last 18 spent at Northwood at Agvice, correct?
Yep.
So we'll turn it over to John.
Okay, thanks. Can you guys hear me in the back? Fighting a little bit about winter cold, but I want you guys to this is our laboratory located in Northwood. I'm sure all of you know that in 2007 the lab and a lot of Northwood was pretty much wiped to the ground. So we rebuilt the laboratory in Northwood there, and if you ever drive by, stop in and visit us anytime. We give tours to farm groups all the time, and it's located in Northwood, which is a very small town, about 1,000 people. But it's one of the more modern soil testing laboratories in all of North America. And so when you stop in there, it'll also give you an appreciation for what happens to your soil samples. They don't just go into a black box and numbers pop up the end. There's a whole bunch of stuff that we do to those samples to get you guys the information that you need. My name is John Lee. I'm a soil scientist with Agvice. We also have a laboratory in Benson, Minnesota, where I grew up, so that lab kind of covers the Corn Belt. And today, Greg asked me to talk a little bit about plant tissue analysis, sampling, taking care of the samples, and maybe another example or two. And then we'll finish up my portion of the program with talking about some soil test trends for the last several years. Okay, how many of you here have ever done a tissue sample of any sort for nutrient analysis? And you knew exactly what every number on that report meant, right? Well, I've been doing this for 30 years, and that's not an easy task, especially when you don't have a soil sample that goes along with it, and we're going to talk a little bit about that. So we're going to talk about plant tissue analysis, talk about the growth stages, we collect the samples in plant parts, how to handle the samples, and then we'll finish with an example from this past summer. So if you think about plant analysis, at least in my mind, it's kind of like going to the doctor. And what he's trying to figure out is what's happening to you right then. It doesn't say what's going to happen to you next week, or if you're not going to get enough food next week, or you're going to get a disease next week and die from it. It's really a snapshot of what's happening at that moment in time. So tissue analysis doesn't look forward very far. It just doesn't. And it's used best when implemented with a soil test, whether that's from the field early in the spring, or better yet, when we have good and bad areas of a field and we get tissue and soil samples from both of those areas. Tissue samples are good for helping us diagnose symptoms. Nitrogen and sulfur deficiencies in the textbooks are supposed to appear very different. In the field, that isn't always the case, and sometimes they come on at the same time, so it's not always easy to tell what the problem is. We can use tissue analysis for looking at fertilizer placement. You can use it to figure out if the starter attachment was having some problems. It helps to figure those things out. And in things like irrigated potato production, tissue analysis is a common weekly event. But in that situation, you're controlling the water, so it's never a limiting factor. So those are places where tissue analysis is commonly used to do. When we talk about plant tissue analysis, we start with knowing which part of the plant to collect. And this isn't something the laboratories determined. This was generally from research at the university levels, where they've done the research over an extended period of time and figured out what plant part it was they needed to collect that was a good indicator of the nutrient status of the crop. And that changes as the plants get older. And we'll talk about that in a little bit. And then if you're doing a comparison in a field where part of the field has an issue, you can see there's obvious symptoms out there and the rest of it's looking good, we would like you to get the tissue analysis and the soil samples within a week to 10 days of when those symptoms appear. Because if you wait longer than that, it can confound the issues with the tissue analysis, because one nutrient can cause trouble with the uptake of others. So we want to get that tissue and soil sample as soon as you see those differences. Just some general things for collecting samples in the field. Many times you have rain splash early in the season when the plants are small, and you'll collect the tissue just the way we tell you to do it, but the soil is on the leaves. Brush that off the best you can, because that causes trouble with iron and manganese on the report. When you get a report back and the iron and the manganese are off the chart, just know that that's from the soil contamination. You can't really wash the samples. We've tried that. What you do is you end up washing some of the potassium out, which we don't want to do because that can be a problem. So we basically just have to put up with the iron and manganese numbers being high from rain splash. Just brush the most dust off the samples that you can. And then keeping the samples, either shipping them to us right away or keeping them cool is important. Because if they get moldy, and I'll show you some examples of that later, we're going to call you and say the sample's no good, we need a new sample. So take care of them the best you can or ship them to us right away. Okay, some general things early in the season. Early in the season when you're collecting tissue samples, for the most part we're talking about the whole plant. And I want to make this perfectly clear, the whole plant does not include the roots. Never send us the roots, we get lots of root samples and we don't ever want that. So with wheat, you're talking tillering, the whole plant above stage, above ground, corn up to 12 inches. But when you get to the middle of the season, generally it's a plant part. With corn it would be ear leaf, with small grain it would be flag leaf or the top leaves. And the other thing is, when we tell you we want 50 flag leaves, for example, on wheat, we need 50 not because that's a magic number, but because it gives us enough plant material once we dry it down to do the testing. That material is 90-95% water, so when we get it all dried down, there's not much left. You can look at any of the guidelines for taking samples on our website. Just go to agwise.com, click on Interpreting the Plant Report, Soil or Tissue Sampling Protocols. It's all right there for you to look at any time. So here's just some examples. Spring wheat, whole above ground, a tiller and clip it off half inch above the ground and give us about 50 of those. Flag leaves, again, smaller plant part, at least 50 of those is what we need to do the analysis. And this would be for winter wheat, barley, grain crops, all would be the same. For corn, early on, again, up to 12 inches tall, we want the whole plant above ground. Later on, we're talking the recently mature leaf. And you can know recently mature leaf on any of these crops by looking at the top down and just going down until you get to the first leaf that's actually full size. And that would work for corn or soybeans. Any of the crops, recently mature leaf, just go down to the first leaf that's about full size, and that's the one we want. Later on then, in the stage of the crop, we'd be talking about the ear leaf, and that's the part that we would want. Generally 20 to 25 of those. Early on, when it's in less than 12 inches tall, we need about 20 to 25 plants to do a good job in the laboratory. And it's no different than collecting a soil sample. If you're trying to collect a tissue sample from across the whole field and represent the whole field, you need to get plants from all over the field. Generally speaking, tissue sampling isn't done that way. It's done to figure out what's going on in an area and then be able to go back to that same area and get a soil sample and follow up. Soybeans, again, whole plant part, whole plant early on. Later on, we're talking about the first fully developed trifoliate from about 25 plants. Again, first one that's full size. When plants take up nutrients as they grow, the research from the universities basically has told us that the nutrient has to be at a certain concentration to be in a sufficient range. So on this side, we'd have increasing yield or growth. As that nutrient level gets higher, it could be nitrogen or phosphorus or potassium or any of them. And what we're trying to hopefully manage our fertility program is to keep each of the nutrients in that sufficiency range. If we happen to get too high, there can be some toxic effects. And we all know that if their nutrient level is too low, we're going to lose yield and our vigor and all along the way. As plants get older, we actually expect the nutrient concentration to decline. Even in healthy, high-yielding crops, that's what we expect to happen. So you'll see different ranges for the crop. For nitrogen or potassium, for example, when it's in its small stages versus when it's in its larger stages. Some of that's based upon just differences in concentration with the age of the plant. Some of it's based on the fact we're actually collecting a different plant part. And I'll show you an example of that. And there are also times when, if there's way too much of a nutrient in the soil or applied, you actually get test levels that are way above the sufficiency range. The plant's just taking up more than it needs. That happens with potassium quite often. Here's an example of what happens to the sufficiency ranges in corn as it gets older. Early on, we like to see 2.9 to 5% potassium, and then that drops off as the plant gets older. That's what we expect to see. That's okay. That's the way it's supposed to work. Much of the research came from the 60s, 70s, 80s at the research from the universities. That hasn't been an emphasis recently. We're hoping that they might do some more of that in other areas to redefine some of the sufficiency ranges. People argue that crops are much higher now, the sufficiency ranges must be different, must be higher. I don't know, I suspect that that's probably not the case, but probably would be nice to have some research to show that. But most of the research, the sufficiency ranges that we use come from university research. On many crops outside of corn and soybeans, and wheat, for example, it's hard to find really good sufficiency ranges that are based upon research that you know where it came from. And so, and if you do find it, a lot of times it's older information. So that is in question, and we get questions on that quite often. When we receive tissue samples, we dry them down, we grind them up to a powder, and then we test them. And so what we need is a good quality sample to arrive at the laboratory. This is the envelope that we give out to our customers, and they're basically like a mailing envelope, and they have holes poked in them. They have holes poked in them so the moisture can be leaving the tissue sample so it doesn't get moldy in the shipment to us. And if they get moldy, the samples get wrecked. The quality goes downhill, and the numbers that we get on them aren't as good as they could be. Sometimes people will use our envelope with the holes poked in it, but they'll push too many tissue bags into a cardboard box and seal it up, and it might sit over a weekend before it gets to us. And then you start seeing little bits of mold show up on the tissue samples, and we call them and we say, don't do that again, next time they might be worse. And then once in a while people will think Ziploc bags are a really good way to take tissue samples and send them to us in, and all they are is a really nice incubator. And in one hot day, they turn to mush very quickly. They just turn to slime. The same smell you have if you leave the grass clippings in your bucket too long, that's what they smell like when they get to us. So don't ever use Ziploc bags, please. So the samples come to us, we put them in a dryer overnight. By the next morning, we grind them up in a Wiley mill. And that's the powder that we start with, that we put into the different instruments. Some is digested, some is put into an instrument for combustion procedures, but that's what it looks like. And that probably was about 10 or 15 corn leaves. There's not much there when you dry it all down and grind it up, and you lose a little bit in all the processes, so make sure you give us enough. So we want tissue bags with holes in them, some moisture escapes. You can use paper bags, that's fine. We want to try to avoid the mold in the Ziploc bags. So when we do tissue samples for growers, we always encourage them to give us a tissue and a soil sample so that you can make the best decisions. And also to know as much as you can about the field situation. What's happening out there? Is it dry? Is it wet? What fertilizer was applied? When was it applied? Timing, rotation, what was the previous crop? All that information is helpful in figuring out, along with the tissue and soil samples, what's going on. So we want them done together so that you just make better decisions. This is one example from last year that I wandered across because it was close to where I do my deer hunting. 2 cornfields, sandy loam, well-drained soil over by Hatton. Adjacent, they both had dry beans the year before, and one of them, when it was in about 5 or 6 leaf stage, started turning yellow. You know, last spring, cool, wet, that area had its share of rainfall, and a sandy loam soil would be one that's easier to leach. And the field right next to it, seeded 1 or 2 days before or after, it was green. Same stage, obvious differences. So I went and I talked to the farmers and I said, okay, what's the deal? So the guy with the green field, previous crop was the same. He applied NPK and S fertilizer before planting, and I said, well, what was the soil test? And he said, I don't soil test. I was really broken-hearted there. And I said, what did you put on? And I don't remember what the numbers were, but it was a lot, and it was NPK and S. Nothing was going to be deficient on this field. And so then I talked to the other guy who I know a little bit better. He soil tests, and he told me what he put on, and I said, well, you know, I think it's sulfur deficiency. Did you put any sulfur on there? And he goes, no, the soil test was high. And if you think back to the fall of 2012, most of the soil tests were high in sulfur. But of course, this is a sandy loam soil, and with the rainfall we had there, my guess was it leached the sulfur out, so I collected soil and tissue for both fields. This is the striped, you can see that striped field. If you had any corn last year, you probably recognize that. There was a lot of striped corn out there. And the tissue sample, again, everything above the ground, we clipped it right at the ground. The total N in the plant, in this yellow plant, was 4.9%, and the sufficiency range is 3.5 to 5. So the nitrogen was fine. Nitrogen wasn't the issue. I took a soil sample in that same area, and a 12-inch sample was all I could get. There was 78 pounds in the top 12 inches, and plants this small don't require a whole lot of nitrogen, so nitrogen should have been fine. The tissue test said it was fine. The soil test seemed to have plenty of nitrogen in it. And then we looked at the tissue sulfur levels, 0.13%, with the sufficiency range supposed to be 0.25 to 0.5, so it was half of what the low end of the sufficiency range was. And the sulfate soil test on a 12-inch basis was 22 pounds, and again, sandy loam soil. So the tissue test told us it wasn't nitrogen, and it was sulfur. The soil test said nitrogen's pretty high, and sulfur is, I don't know, it's hard to define that critical level on sulfur from a 12-inch tested season. We don't really have that kind of information. So now let's go look at the green field. Same kind of sample, whole plant, row ground, tissue N, 4.6% in the plant, well within that sufficiency range that we were expecting for that stage of growth. Soil nitrate was off the chart. Like I said, this guy didn't skip, a lot of nitrogen there. And you look at the tissue sulfur levels, 0.37. It's in the middle of that sufficiency range that we would like to see. Sulfate soil test was 104 pounds, which is, I think, a pretty high number for a 12-inch sample. So again, nitrogen was fine on the soil, sulfur was fine on the soil, nitrogen was fine on the tissue. I mean, everything was good there, and the rest of the nutrients between these fields were comparable, so I didn't even show you those, but that was the difference. So what was the response? Of course, the guy with the green field, he's smiling, he didn't have to do anything, he was pretty happy about that. The farmer to the south of there, where he just hadn't applied any sulfur and it probably got moved away, side dressed some N on there, even though he probably didn't need it, put some liquid sulfur in there, got lucky with the rain the next day, and in about 7 days it was all gone. Everything looked good. I don't have yield data from these fields, but I'm assuming he got on this fast enough. If he lost any yield, I would be surprised. And everything looked good from there on point. But that's why you have to have the tissue and the soil samples together to really make sense out of it. If you just had a tissue sample from a field and it said 2 or 3 things was limiting, or even 2 things, how do you sort that out without having a soil sample? Tissue analysis doesn't tell you, generally speaking, this one's the bigger problem or this one came first. It just doesn't do that. And it also doesn't tell you if something's going to run out next week or the week after that. It's not very good at telling you those things in advance. So it's really good to have those tissue and soil samples together. So to wrap that up a little bit, good and bad tissue, good and bad soil, to figure it out. Make sure you give us the right plant part and enough of them. If you're not going to ship them to the lab right away, refrigerate them, that's fine. Soil sample, 0 to 6 is fine. If you can get a deeper sample, that's even better because it helps us to know more about the mobile nutrient status in the soil, like nitrogen, sulfur, chloride, things like that. Any questions on the plant tissue part of this? And I've gone through this pretty fast, and like I said earlier, if you all could understand every tissue report that came back to you, I'd be very surprised, because it's just not a simple thing.
Do you have a midstream question on that kind of tissue sampling side of things? If it's at, say, V5 or whatever stage it's at, and you have X amount of the soil piece too, and you know that you have 76 pounds or whatever you have in the ground, do you make any recommendations, either just based off your tissue analysis of what it needs to finish out at an estimated yield of 200 or whatever it is, 100?
We don't actually make any recommendations from the tissue analysis or actually from the soil analysis midstream, because you never know for sure how much nitrogen would be in the crop, for example, or how much nitrogen may have been leached or denitrified. In a perfect world, that would be great. Then we could just plug it in and say, oh, yeah, you got to apply this amount. The problem with that, besides those other things, is differences in temperature going forward. So is the soil going to warm up and produce a bunch more nitrogen the next couple of weeks, or is it going to stay cold for 3 more weeks? Nobody knows those things, so that would be great if we had that. We just don't have that. I think a lot of this just boils down to common sense. If you know what kind of rainfall you've had recently, what kind of soil type it was. Is there a big difference between a soil test of 25 pounds of N left in the top 2 feet versus 200? You know, common sense, I think, plays into it. If you end up in the middle, that's where it gets to be tough. There's 75 pounds left out there. Is that enough? Is it going to rain another 5-inch rain 2 weeks later? You guys have to make all the tough calls, right? That's why you make the big bucks. It's not easy, but it's another tool to help you figure things out. It's not perfect. What he asked was, when we do the analysis for calcium, magnesium, potassium, what do we make the recommendation based upon? The test is for calcium, magnesium, potassium, and sodium is all done on what's called the ammonium acetate extraction, and it's considered exchangeable. And so the base saturation is then just a calculation based on those part per million values to get some ideal ratio in somebody's mind. That's a whole other talk, but that's a fictitious thing. It doesn't exist. What we do is we make a recommendation for each of those based upon if that nutrient is sufficient or not. The best way I can explain why those ratios don't work is, for example, what Greg was talking about this morning on the soils that are salty. If you use the routine test and you look at the calcium number that comes out of it, it's inflated because that calcium number is supposed to represent the calcium on the exchange that's held on the soil, but it doesn't represent just that. It represents calcium in the soluble salts that are floating around. It represents calcium in the carbonates that are in the soil. So it's an inflated number. So I don't know how you could use an inflated number to come up with some magical ratio because it just doesn't exist. And the people who tell you that that's the way to do things, just remember that if any of those ratios are wrong that they're talking about, the end result will always be that you have to apply more potash. Doesn't matter what ratio they're talking about. And if you hear it late on television tonight, the end result will always be that you have to apply more potassium. Okay, I'm going to finish up with just some information on soil test trends. Nitrogen is usually the one people want to talk about most. Environmental factors certainly have an effect on how much nitrogen is left in the soil profile each year. For example, 2012 was a warm year, lots of mineralization. One of the reasons we probably had more carryover nitrogen than normal. Whereas compared to 2013, many areas were wet, and may have been part of the reason we didn't have as much nitrogen left over. Practices are important, what rate's applied, when it's applied, placement in some cases, tillage, and of course yield. If you have a lot of yield, generally speaking, the carryover is a lot lower. Some historical perspective. How many of you were here in farming in 1988? There's a few hands out there. That was a really dry year. I took the lower unit off my boat that year and did a double cycle. That wouldn't happen anymore. So, the average wheat field in that year averaged 107 pounds of nitrogen carryover. That really sticks out. And the few years after that, the carryover was high as well. Why do you think that was? Farmers primarily didn't believe their soil test and wouldn't put on just a starter. So it took years to bring that back down. The production was pretty good after that when it started raining again. But it was pretty hard for them to not put nitrogen on at their normal high rates, especially when it was 6 cents a pound. So they put on extra and a lot of it lodged. You said that hasn't happened since then because farmers know soil tests aren't perfect, but they know it's a pretty good tool. So if it tests really high, they generally back their rates off quite good, which is good. 2013, the average was 34 pounds across probably 30,000 wheat fields. And that's not the lowest one ever, but it's right down there. So carryover following wheat in general was pretty low. You're going to see a few maps like this. There's the state of North Dakota. And what we generally do is we summarize the data by postal code, zip code, where it comes from. That's about as good as we can do in many cases. And these are just highlights of the areas that had higher nitrogen carryover than, say, most of North Dakota. And most of these are very explainable. This area up here, south and east of Winnipeg, hog production. A lot of manure application. So this area always has more carryover. You get down to these parts of South Dakota, they were actually really dry. So there was more left in the soil because the yields were probably not as good. So we would be actually right on the line probably between these. We'd probably be right located here, about 40 pounds as the carryover following wheat for 2013. Here's 2012. If you look at those numbers, they're a little bit higher, and if you do a comparison, there's the difference in the average. And of course, the average doesn't mean anything about each of your fields, it's just about the region. But from a perspective of the whole state, 10 pounds lower soil tests this year amounts to about $28 million more nitrogen fertilizer that'll have to be bought if you grow corn or wheat or another nitrogen-bearing crop on those 5.7 million acres. It's substantial. So nitrate testing is important. Now here's the information that pertains to each of you. This is a breakdown of the number of fields, wheat fields, that fall into each of these categories. Of course, there wasn't very many testing over 100 pounds this year, whereas last year there was a fair number, maybe 10%. There's 70, 80% of them down here, basically. And you might say, well, can't I just guess that they're all 20 pounds? We could. But maybe there's one out there that's 40, and that's $5 to $10. And if you looked at those budgets that were presented earlier, that might be the $5 to $10 you get to take home. So you want to just know where you're at. Corn. Here's the average following corn production in 2013. And what's the thing about corn production? Generally speaking, guys aren't afraid to apply nitrogen to corn, even if it's a little too much, because it doesn't lodge like wheat. The only downside is you probably bought more fertilizer than you needed, generally. So here's the carryovers, averages from this year. There's from 2012. Look at those spots again. And this was really dry down there, 2012. Average cornfield, 114 pounds out there. And again, there's those average differences from 2012. So there's a lot less nitrogen left over. It could be, it probably isn't yield so much, but we had no nitrogen losses basically in 2012. Dry. Little denitrification losses, very little, if any, leaching losses. We just didn't lose it. And we get so used to losing nitrogen through the wet years, we kind of get used to that. When it didn't happen, you know, we had good high carryover. But this year, carryovers were quite a bit less. And then there's the breakdown again of each of the categories. You'll see only 21% of the cornfields had really low nitrogen left over, and there's a little more of a bulge up here towards the ones testing 60, 80 pounds. And that's pretty common. What about the other nutrients? Phosphorus, for example, doesn't move with water, not really affected by temperature, more affected by farmer practices. What rate's been applied, if there's been any deep tillage which can make the soil tests go down. And sampling depth consistency is always one that comes to play when farmers say, what do my phosphorus levels do like this? It's something that you have to, it's a struggle to get the same sample every year. Percentage of samples in phosphorus testing less than 10 parts per million, these would be the ones that would require a decent application every year. As you go west, you can see 70, 80% of them need decent applications. As you get to areas that have a history of higher applications, only about a third of them test low. So you can see practices there. And in the small grain going areas, we pretty much put our starter down with the grain and keep our soil tests where they are, and we don't really try to build them. Some long-term trends here. The bottom line here is the average soil test phosphorus coming from the Northwood Laboratory, which would cover North Dakota, Montana, Manitoba, areas to the north. This top line is the average phosphorus soil test from our Benson, Minnesota laboratory, which is 2 hours west of Minneapolis, which would represent more of the Corn Belt. And you can see their average phosphorus level there is just higher. More years of application, I'm guessing. Higher rates. Potassium. We're blessed with soils that have a lot of potassium in this area, and this is the percentage of fields that have less than 150 parts per million. That's kind of the breaking point. And as you can see, you know, when you get out west, there's not very many that test low. So a soil test will basically tell you either you don't have to apply very much, or the amount that you need isn't probably too much unless you're on some of the sandy ridges. Sandy soils will definitely require some potassium, probably. Here's the critical level for potassium, 150 parts per million. Here's the average potassium test of the samples that come to North Dakota, to the Northwood lab. There's the drought. Potassium is affected by soil moisture, so that really sticks out. Our Benson laboratory, serving the Corn Belt, you can see their test levels are down around 200 parts per million, or maybe a little bit lower in some years. So it's more of a big deal for them, where they have had more history of removal with corn and soybeans, and soils that just don't supply as much potassium. Soil pH, northeast North Dakota is where I live, 582 zip code, 58102, like Grand Forks area. You see over 20 years, pH really hasn't changed. But when you put all the samples together, you can see a downward trend there. And that's something that we didn't notice until we put all this together last year. It's real, and it makes sense. We also actually, if you look at your soil tests from this fall, we actually started offering or providing the pH on not just the topsoil, but on the subsoil as well. Because when you have a topsoil pH less than 6, that would generally require lime. But in our area with subsoils that are higher than 7, we don't think you probably need any lime. So without this subsoil pH, we weren't very confident in knowing if the lime would make sense for you. And so in eastern North Dakota, 3.5% of the samples would have a soil pH less than 6 that may require lime. And of that percentage, only 1.7% actually have a subsoil pH less than 7, meaning most of them don't need lime. But without that test, we just wouldn't know that. So you're going to see more pieces of information like that on your soil test. You'll see that subsoil pH now going forward. Salinity, Greg talked about that a little bit this morning. This is the sweet spot, or sour spot, depending on how you want to phrase it. 30% of the samples in this area of North Dakota have a salt higher than 1, which would cause trouble for soybeans, lentils, peas, things like that. But that's actually gone down considerably from the year before. This is a long-term perspective. The percentage of samples in that area testing higher than 1, and this is what happened in 2013. We had enough moisture in those months to actually move some of that down out of the topsoil. And we saw it in other areas. We even seen it out west where there aren't very many. And so the percentage of samples testing higher than 1 actually went down. We saw that across South Dakota as well. One slide on zinc here. Percentage of samples testing less than 1 part per million, with zinc being probably the only micronutrient that's of much concern for us. I'd say about half of the samples, up to 75%, test less than 1, and that would just be an indication for you to maybe put some zinc in the starter. Sulfur, kind of a moving target. These are the percentage of samples from last year that tested less than 15 pounds per acre in the topsoil. The year before, 2012, in a dry year, that would probably double. And on those heavier soils that don't really need sulfur, it's not a big deal, but in the lighter soils, it can be moved away just like the nitrate can be with extra water. A little perspective on what's happening as far as the samples we get. This is the percentage of samples that we get at our Northwood laboratory that are grid or zone samples compared to field composites where the whole quarter might be represented. In the last several years, now we've gotten up to 40% of the samples we get now are not from whole fields. They're from parts of fields. In this area, not much gridding going on. Mostly zone, breaking up fields into productivity zones. So that's what's happening in my world. State perspectives, state of Minnesota, the samples we get in the state of Minnesota, 80% of them are grid or zones. North Dakota's at 34, and you can see different areas have. South Dakota, eastern South Dakota has a lot of grid and zone stuff going on now too. So with that, are there any questions? I don't want to get into other time here. So. I'll be around for a while too.
If I'm not zone sampling or grid sampling, I've got an 80-acre field, how many probes do I have to take out of that field to get general?
General rule of thumb is 15 to 20, and to get the best number, of course, you'd want to avoid, headlands, anything that's you think is saline, high ridges that probably don't produce as much as the rest of it, anything that would dry out. So that probably gets you back down out of an 80. It might be only 40 acres that you actually collect those cores from. And then you'll just know that whatever rate you determine from that soil sample, the rest of the field will either get more or less than it needs. And that's what we've done forever. And I'm not saying that's a bad thing. It gives you some information, but as soon as we started breaking fields up into parts, it really makes you think. Especially in those salty parts of the field that keep getting nutrients and probably don't need anything because they test off the chart for everything. Those are the first, that's the low-hanging fruit that you could take care of right away.